What is going on, everyone? Today we are going to be, we're working on the bench here again. We're going to test out this transformer here and we're going to see what is going on. I did, however, remove the capacitors last time, and what I had found was I went ahead and I tested them, and they're not too bad. I think they're due to be replaced. I'll have that all listed in the document here. But what I want to do tonight is test this guy here. And I did take my multimeter and I did test a few of the diodes, and I was kind of shocked what I found out. So what I'm going to do here is what am I going to do? Oh, I want to get my multimeter up here. So basically when playing with the transformer, don't. Unless you know what you're doing or willing to take the risk. This is high voltage. I'm not going to go into detail on what a transformer is, what it does, what each sides do, all that kind of fun jazz. We're just going to go straight into testing this today, and we will see what kind of results that we are getting here, and we will label this in our book as well. Something about that is if I miss something or something's not quite right, maybe someone else be like, hey, that value or that reading does not look good. Not only will I do one sheet, I'll do one with a blank template on it as well, so that way you can actually go ahead and do your own logging, and I'll do that on all projects going forward. So that way you're able to actually have something to compare to, because it's really a pain if you have nothing to compare to. And this way we can actually see what's going on, because then if more people do this, then we can all see if there's a common issue within that device. Now, like I've said, this motor control, or this controller board here, I have in the last year, probably 2 beds with the exact same one, and this is the first one I decided, you know what, I want to open it up. I want to see what's going on. A lot of the time we thought it was just in the controller that the issues were happening. But finally I said, you know what, let's put it on the bench. Let's see if we can fix it. The person is a low income person. They can't afford too much. So, you know, why not see if we can tinker a bit and as well learn something and see if we can't fix it for future reference as well. So what I'm going to do here is on the side here, you can't really see it, but I do have, I'll just show you the bottom here. Okay, I got another power cord here with a breaker on it. Basically what I'm going to do is I want this separate from all my other electronics. So this is going to be 120 volts, and then we want to know the voltage coming out. I'm going to assume that it's 24 volts, but I could be wrong, just because that's usually what these systems are, 12 volt, 24 volt systems. With that being said, this 24 could be split between the 2 channels. I don't know, just so it has enough flow. I don't know. Well, we'll look into it later. So what I'm going to do is I'm just going to get the multimeter on here. So hopefully this will connect in just a moment here. See if I've left the Raspberry Pi on that has the server for this. So hopefully it kicks in soon. I don't have to reset anything. I didn't test that before starting the stream tonight. We're just going to give that a moment here to do its thing. Push this out of the way just a little bit here. And look at that. There we go. So we've got our display here. Right now we are in auto on DC. I want AC. It would have been, that's one thing I noticed there is no, we have, Hey James, can we get, okay, well, we're gonna go with that. So I've got that up on screen there. So so on the board here we have CN1 as the location, is what I'm calling it. So I'm going to be updating my cell or my spreadsheet on this as well. So what I'm going to do is I'm just going to power on the unit here. Hopefully nothing goes sparkety spark, and we will go from there. So we have 23.5556. That's not too bad. Okay. I thought it would have been 24 volts. But I guess that's close enough in the range. I don't know if it is going to be getting too hot or anything like that, but I'm not going to be touching anything here, you know. I'm not going to do that. Do not play with transformers at all unless you are 100% in a safe working environment and you have done it before or have someone there to help you. Don't do it. Stay away from it. Okay. So now we have our reading. I'm just going to let that run for a minute. Just because I'm curious to see if it's going to be stable at that voltage or if we're going to see anything happen. I'm just going to, while that's doing that there, I'm just going to, I think I might change the color on the display here a little bit. But, all right, let's go over to, I go here. All right, so I have my sheet up here and I need that a little darker or something. Okay. So we are on AC. So I did, as you can see on my spreadsheet there, I do have basically the readings that I had gotten from those those capacitors there and their locations. So what I'm just gonna do is we're just gonna go CN1 component transformer, and I'm gonna say it's 120 volts to 24 volt, and reading is 23 point, I'm gonna say, I'm gonna go with the lower value, the 5.2. Okay. So I'm not going, I was hoping to actually get transformer out of there to see if there's anything written on it, but I couldn't really tell if there was or not, so I kind of just left it alone. And it was really tight in there, so I don't know what they have going on there. So that is basically testing that out. Now we're getting a little bit of a, maybe she's warming up. Should that be producing more voltage? Maybe it's warming up. I'm gonna leave it for a minute here. Yeah, so the document, I'm I'm gonna actually update that to our higher value in a moment here. If this goes up a bit, I'll add that to it. So my initial reading will be that 23.54. Get it higher, come on. We rub it, make it go faster. No, we can't. Electricity is so much fun to work with, but you have to respect it and know that yes, it can hurt you and it will hurt you. It will not ask you for its permission. So always work within your skill set. Do not do things if you do not feel comfortable with it. So no taking apart old tube TVs and stuff like that unless you're willing to take a shock or two. Yeah, just be careful, do your research, do your homework, and everything will go smoothly and you won't have any surprises. Okay, so I'm gonna say 23.86. So I'm gonna update that on there. BNC. So we're gonna go. So initial startup was 23.52, and our final warmed up temperature is going to be the 23.84 volts. That's, at least we have a range of where we're sitting. So that's more than acceptable. A small drop like that is not going to break the system. So I'm just going to go ahead, I'm going to power off that guy there and drop power from that. And so that's off now. As you can see there, there's nothing overly exciting happening. Yeah, thanks to the Bald Engineer again. I love this on-screen display here. That way you guys can see what I'm doing and the measurements. I am using the Multicomp Pro MP 730026, which is a great multimeter to use for general electronics work, and it won't break the bank, and it's better than your cheap run-of-the-mill multimeters that come in every kit and package. So definitely an awesome multimeter. And one of the reasons why I wanted this one wasn't because of the connectivity of the cell phone. It was the temperature probe that's on it as well. Sometimes when working with brushed motors or other electronics, it's nice to be able to diagnose things quickly. So riding a scooter, for example, having the temperature being recorded on my cell phone while I'm riding it, to see those temperatures compared to when, you know, it's just sitting idle or being used, or just a stock unit brand new, the comparison between them to see basically if all the motor brushes need to be done. If you change the motor brushes, does the temperature drop? What kind of heat are you getting? What kind of draw are you getting? Yeah, anyways, very handy to have, regardless of what you're doing. We can definitely even hook it up to our Raspberry Pis later on. We'll do some actual real-time heat temperature sensing, that kind of fun stuff. So I've got this guy all done here, so I'm going to get rid of this guy for now. We've unplug it. We don't need this power brick anymore. And the only thing I want to make sure is my wires do not cross. All right, so there we go. And then we can actually just turn that guy off for a moment, and we will hit that guy there. Actually, we can leave that up there just because, you know, hey, who doesn't want a multimeter logo on their live stream? All right. So if you're watching on YouTube, make sure to hit up the Twitch channel. Link is in the description below. If you're watching on Twitch, make sure to check out the YouTube channel. Throw a like, subscribe, all that fun jazz. Make sure to follow on Twitch as well. A lot of nonsense will happen here throughout the week. I can guarantee you that. And the odd time you will see some sparks. They're fun. Okay, so I assume that's going to be a 24-volt coil or transformer. Jeez. So I'm just gonna remove these alligator clips from my probes here because we will be using this again in just a moment here, and I will show you what I had found out and what we will be logging on our data sheet here. So okay, those are removed. I'm going to put those back in the bag. And then I will show an example here. So this here is a bin of what we call diodes. What is a diode? It's a fancy way of saying power goes one way and not the other way. Or prevents it from. We like diodes. Diodes are fun. So here is, oh, that's a pretty big one, but I do have some diodes here. Hopefully I got enough to do this board here, the right values anyways. So once again, I'm going to put my meter into that fancy little diode icon on my multimeter, and I'm going to get the multimeter connected to Bluetooth again here so we can bring that display back up on the screen. And it does just take a minute for it to connect the first time. What I could do is basically just leave my meter on until, you know, and then just kill the screen. But anyways, all right, so we are on this guy here, and basically what we want to do is, I don't know, try there, go like this. Okay, so that's shorted. Okay, so if we go to our diode, we go on this side here, we've got a 0.02 reading. Okay, and then if we go the opposite way here, we have really? I have it in the wrong mode. All right, there we go. All right, let's try this one more time here. So if we go on to this side here, we go here, and then we go here. We're gonna get a reading. And if we go this way here, we have the OL there, the over limit. So basically no current is going through this way. So this way, we get a reading. The other way, we do not. Good to know. Now, if we go to our guys on the board here, I'm just going to zoom in just a little bit here, get you in focus. And basically what we'll do is, so go this side here, this side here. We should be getting a reading. Got 408 on this back one here. Flip it around. And we should get nothing. But what do you notice? we're getting a reading on this way. We should not be getting that. So what does that tell us? This one here should have a reading, and this way should have a reading. I think this is broken inside here. There's no longer anything going on there. Now, this is a common issue throughout this board. So, so what I need to do is remove all of the diodes, mark them on my sheet here. And then after I do that, I have to remove every other component here and basically test them one by one. Now, I don't really feel like solder or desoldering tonight. I think that might be a tomorrow kind of thing. Yeah, tonight I just wanted to just kind of hang out and tinker a bit here. So this here will get completely, so I will remove them. I do need to get the values off the diodes. Yeah, the capacitors will all be replaced. Resistors we can check over, make sure nothing is wrong there. Yeah, obviously something happened in here. Like I said, we're only getting one relay that's working, so we will test the relays as well, and we'll go through them. Now, I find the easiest way to do a lot of the testing, like you can certainly do it on the board if you wanted to for a lot of parts, but I like to have it separate from the board just when there's that much stuff going wrong. Yeah, so we have diodes that are definitely blown or not powering correctly, and even on this side here, those guys down there I think are really bad as well. They're completely garbage. Yeah, I think all of them are basically done. So we will get this back to a working state. I just need to remove a lot of these components, so that way we can, well, you know what, let's just, I say that now, but we should just actually just keep going on it, because the sooner we get it done, the sooner they can get their bed back, right? Back to working. So I'm gonna get the soldering iron, desoldering iron going, and then I'm going to, I gotta get some stuff here, so I will be right back in 1 minute, and then we will start removing components, making a line of them there, and then we will be adding them to our list on here, to what is going on with them after we test them. But I do want to, okay, I think we are back now. Let me just double check here. Okay, we got microphone, we got camera. All right, so while that was happening, I managed to get my soldering stuff set up here. I don't know what went on there, but my bit rate went crazy, and then it decided to kick me off. So yeah, we'll go with it. Anyways, back to what we were doing. Basically what I'll do is on YouTube, I will just cut these two together, so it's one stream on YouTube. So now what we want to do is we are going to start removing components and start labeling where, I think that would be CN2, right? Or CN1? I don't know. Q4, Q6, Q1, Q3. Okay, I'm gonna go with that CN1 down here. Anyways. So what I want to do is power up the desoldering iron, and we will bring up this guy here. So similar to what I did with the capacitors over here, these ones here, I'm going to remove them, put them in a line, and try to remove them in the lowest to the highest value, and then we can actually put those in our sheet a little bit nicelier, and we'll go from there. That being said, let's find E1 is there. Yeah, and then we can actually, I would love, I think I'm going to remove, we're just going to go right for the diodes first. So, and then we'll go from there and just kind of tinker around. I do have my slowly getting up to temperature here. I guess I do not need multimeter on right at the moment here, so we're just gonna turn that off. Go. And take that off. You know what? Like I said, kind of nice to have that little multimeter logo there. Anyways, maybe someone will realize we're doing something with you know, electronics. Always fun. But like I said about those transformers, you just do not want to play with them unless you are more than comfortable. I don't want anyone getting hurt because I did it on stream. So do that at your own risk. Okay, so we are up to temp here. I'm just gonna pin this guy a little bit here. Melt solder quicker that way. Don't want a dirty tip. Nobody likes a dirty tip. Still playing with the temperatures on my desoldering iron. So E1. Well, what's K1? Okay, so that's probably the relays that are the K's there. D1. Because it's the only one that makes sense. Here. Do her thing here. Not Mother Nature. Okay, that should be one out. Check that. Maybe grab my tweezers. Don't need the big tweezers for this one. All right. Move D1. Oh, D1, D4, and D5. D4 is right here below it, and D5 is right beside it there. So we're just going to remove those two guys there. That one there, and you know what? We're just going to take out guys beside it as well. I believe it was this guy here. Pretty good. I'm going to remove these 9-volt battery connectors here as well for the time being, just because they are all falling off. So let's just get rid of them for now. They weren't using them anyways, so two, three, four. What's that? Move it anyways. Worst case scenario is we just probe this later on and just make sure that yes, this is positive and negatives when we put the connectors back on. I think okay, so there was 4 there, and there's another 2. Oh, D2 is over here on the left here. So I'm going to go ahead and get that guy removed because that's our next one that we need. Right? Helps if I look around the board a little bit. Okay, there goes D2. So we got D1, D2. Okay, where's D3? Obviously a D3 in here somewhere. 6. Okay, so I'm thinking there's D3, D4, D5, D6, 7, D8, 9, D10. Okay. Interesting. Okay, so I did try to two guys here already. So I got D1, D2. There's no D3. I pull D5 up, D4. I can D4, D5, and as you can see, I have them up here. So we got D1, D2, D4, D5. If I find a D3, I will add it to the mix. 6 is right here. Get this guy next. That's gonna be. Where are you gonna be? Here. resistor, resistor here. Down here. That is D6. Got D7 and D8 down there, so let's remove this guy here first. Get that guy out of the way. 6 just pops right out. There. And then we got, yeah, D7 and D8 are just on the bottom here. There, maybe. Try that. Come on out. We want the one right beside it there, but I want to make sure I have these all in order, so that way I can get all the values correctly. Locations. Seven. Now we'll go and find those holes there, and we'll go right beside it. A it out of there. Right one. Oh, I don't think that's the right one. Oh, there. I think it's this. That was a resistor I was pulling out there. Come back to that resistor later on and got it. Try to lift that guy out. Okay, so that's D8. D9 right in behind here, and D10 right here. Need my tip here just a little bit. So D9. Out. All right. Thing. There. This. I believe it's this one. One of them. I think the other one is here. Okay. Let's see if we can pull those ones out. So D9. Skip right. This skip. Work that open a little bit. Maybe that'll do it. Get this other side up. That was D9. D10. Oh, that one just came up like butter. All the diodes listed above there, so we will test those out, put them into our readings there. Kind of confuses me. Where's this other D3? Seeing a D3 on the board here. Oh, D3 right here, but that we'll have to look up and see what all about. I'm not going to remove this quite yet here. I'm going to leave that for a bit. We're going to just do one sheet at a time. Of course, based on our list here, I have D6 as a capacitor. Where is D6? Oh. Okay, it's supposed to be C5. C5 is that one, which I thought was D6. So this capacitor right here, that is going to be C5, not D6. D6 is the diode. Okay. So all we need to do for that for right now, right? And this guy back here. All right, now we got that all taken care of. Let's see here. I'm just gonna quickly update that document there. Hey, where'd my VNC go? Why aren't you showing up? Where's VNC? It's saying it's on. Off, on. I gotta turn that off. Maybe I need to restart VNC. Let's just close those out. Okay, let's go here. I'm just gonna close it right out. VNC. No advertising going on here at all. All right, so D6 is actually C5, right? We'll update that. or something happened to my VNC. Go here. Maybe we got, oh, there we go. Okay. We got it back up and going here. Perfect. All right. So let's go D6, and that is going to be actually C5. So I'm going to go here and insert row below. And I'm just going to copy this, paste that there. Then we'll delete this one here. That. All right. So what we have here for the diodes is D1, right? So D1 was right up in this corner here, up in this corner right here. So we will add that. So I'm just going to bring that back. And that's where we're going to start. D1, that's diode. I don't know what the value is. We will finish those up. D2. The D3 is over on that other thing, so we're skip D3 and we're gonna go D4, right? D4, that should be, yep, D4, and D5, D6. D6 was, where was D6? Okay, D6 is that one that I thought was C5. Okay. D6, D7, D8, right? What else are we missing here? D8 and D9 and D10. Okay, so D9 and okay. Oh, I wonder what. Oh, 1N400. 4007. Okay. 1N4007. That's going to be the first one. And I'm just going to go through each one so I know the value of each diode. Okay, so I'm just going to make another row over to the side there. And 4007 again. And on capital N, please. Thank you. Aye, stop that. 1 and 407. Okay. The first two are the same value. want to make sure that all values are the same. And 4007. Okay, so the first three are the same values. 1 4 1 and 4007. I'm thinking these are all pretty much the exact same thing, but you don't know unless you check. So that next one is our D5 is 100% 1N 4007, and looking at these on I am certain all 1 and 4007 kind of sucks. I only have 4004s. I'll just have to order them. I would rather put the right parts that came out of it into it. Like this. And yeah, basically I'm just looking at it. Once again, this is where having that microscope would be kind of useful. Roll it around on there. What do we got here? 1N4007. All right. Update that guy again. 1N4007. Okay. And yeah, these are all going to be the same, guaranteed. 100%. 4007. Why do some of them look bigger than the others? I don't know. Maybe they're the ones that are no good. That could be. 4007. All right. 1N4007. Okay, and basically what I'm doing here is just making another row the way I'm looking at them here. That way we know what diode they are, and then we still want to actually test them all to see where which ones are good, which ones are bad, which ones are super ugly, and be able to kind of follow that on the board where something might have gone wrong. This could have just been a power surge or something, and that just too much voltage and it spiked, and there's nothing you can do about it, right? So, and so the D10 we are looking at 1N400, and of course it's a 7. All right, so we've got that. I'm going to update the sheet here. 1N4007. Okay. I just want to try something before we go any further here. Try a little thing here. You know what I mean? Anyways, I got a little thing here. I want to try something. I don't know if I can do diodes on this. Let's find out. Okay. So it looks like we can. Okay. So I'm going to get this out of the way for just a moment here. And I will bring over this guy. You see me? I can't even tell. All right. So I have this ESR meter, and it works fairly well. Darken this a little bit here. Yeah, basically now all we're gonna do is we're gonna go, like, we could use the multimeter to test them all, but once you use a multimeter, it's always fun to use other tools too. So I'm just gonna go ahead. I am gonna plug this in because this is actually gonna produce more data for us. just going to go there. I'm going to power on test or power on, and we will see what we have here. That is really hard for you to see. Let me just try to get some light off of here. There we go. Okay. And all we're gonna do is up. Hey, didn't need to hear myself there. So the D1, I'm just gonna input this data onto the sheet here. So whatever it produces for me is the data that I am going to add to it. So equals 672 MV, and then C equals 12F. Okay. Then we are going to remove that, and we're going to start another row for this stuff. So I'm going to do one row of it and through plopping them in and seeing what the test results are. Go. I'm just going to power it on and test. So this is D2. 673. Oh, equals 673. Eight. And got to remember all of these diodes are the same, so they should be basically the same thing throughout all of them. Like I said, we could just run the multimeter on it and just check, and I'll probably do that yet. And we'll just double check all the diodes and see which one is actually reading both ways. Bugger. Leads are a little bigger than the others. Here. Power that guy on. What are we sitting at? Yeah, so that one is producing the same as basically the other one. Hey, why aren't you typing? Board turn on. Okay, so with 664 and 12, was it? 671 and 12. Going down the line. Oh, turn off. Turn off, man. Oh. Needs a bit more here. This one here. Uh, 662 and volts and equals. Okay, so now we're gonna check out D6 here, right? Because we did D1, 2, skip 3, 4, 5. Are on D6 right now. that guy going. And just so you are aware that yes, this is what we are actually logging here, all our results. So and then we will do a test on I might have to go back on the video and update this after. I think I'm missing some data, so okay, we will come back. Oh, D7 646 46 and 10. Hey, I hate that the backspace does not work the way you would think it would in there. And then C. Right, down to D8. That guy back for you. What I'm doing. But yeah, it looks like some of these are producing some other data on there. So something's going on with a couple of them. So UF equals 1 volt equals that was D8. That on. Now I think F equals 658. And now for the last one there, hit the button. Alrighty. These guys are done. We can power this guy off. Lose my row here. Alright. So that guy's off. We don't need him anymore. Zoom that back out. As you can see, I do have my row sitting there still. Just gonna open a little bit. Let's brighten her up. Alright. Those are all tested. I've tested these guys. We don't need those here. No, that must be it. So once again, D1 on the left, all the way up to D10 here. There's no D3. D3 is actually this guy right here. So now what I want to do is I want to get the multimeter going again here. Get the Bluetooth going here and get connected. Wait for things to happen. All right, so start with the first one here. Oh, that's terrible to look at. Look at it this way. Let's flip it over. There we go. That's a little better. That, and we'll bring that down here like this. Go. Diode platter. All right. So when we connect this way, let's see what reading we get. Okay. Now if we flip it around, that's a good diode. D1, D2. Basically, we're just making sure voltage is not going both ways. So we should have one reading this way. Flip it around here. We should have it stay on OL. Come on. Okay, so that guy's good as well. This guy here. 0.5. This way. And so far D1, D2, and D4 are good. Around here, let's make sure we're in the right spot here. Here, and we'll go here. Okay. Around. Good too. Where's all my bad ones? In circuit, they were showing up bad. So what's going on? Back here. 2.4. Okay. Okay. Maybe the diodes are good. So it's with the weird readings. Okay. Back the other way. Nada. All right. Fine. Looks pretty good to me. Wondering if I had some, no good or no bad ones in here. I was just in the circuit that was. Well, that's pretty good because then I can reuse these diodes. Might change them out anyway. Maybe it helps if I'm in the right mode. Maybe. They're good. I think they're all good. Okay. But now we know what so in circuit I was getting a different reading. Yeah, I'm being really cautious here and just testing them all again. Oh, look at that right there. So this is the way I should have started to test, but when I turn it around now, fine. No, that's fine. The what? I don't get why in circuit it would actually be producing voltage both ways though. I think they're all good. Right. This one. This is D1. Last one to actually test here. Okay, and okay, I going with those are all okay. Might just swap them out anyways if I have some available in my kit. Don't bump the camera too much. Right. So yeah, the next thing would be to just start removing. The weird thing was it was actually so it would actually have in here both ways. It would show that it was voltage going both ways. So is there something else? But really, we don't have too many components left to remove off of here. We are going to check this guy out. We're going to check out these cement jobbies. Jobbies, that's the proper term, right? Yeah, we're just going to go through it all. Basically strip the board. But I think that's going to probably do it for me for tonight. One thing I'd like to mention, I do have some big news coming up here soon, which is kind of cool, but I ain't going to tell you yet. I will wait until things are more finalized. We might even have something, and then something. That's all you get. Okay, so that's going to do it for me tonight, guys. Tomorrow we will pop a bunch of the other components here. I do have yeah, I'll go through my list here. I'm gonna review the video. I want to see what a couple of the readings were, just to update my notes here, because I don't think I looked at it completely correctly when I was checking it. And this is why it's good to check both out of circuit, and that way you don't get a false positive, or something is actually causing an issue elsewhere that's giving that error, or that, you know, spike in voltage or something shorted out anyways. Oh, sorry about that. Anyways, thank you for watching, everyone. You have a wonderful day, a wonderful week, and we will see you, well, tomorrow if you decide to you know, come on by. So thanks again for watching, everyone. Don't forget to follow, subscribe, like, all that kind of stuff. Leave me a comment, and yeah, we will carry on with this project and hopefully get this done in the next day or two. All right, thanks for watching.